And secondly, is that again find a random object, and then by use a rubber band on one of the sides, and then on the other side you use your fingers to hold it and keep it at rest, and then release your finger maybe in this diagram on the right hand side. What will happen to this box? And you can also do it at home. Just find a random object, a piece of rubber band, and then to hold the object, and on the other side your goal is to make this object remain at rest. So when you're drawing the free body diagram, or you would like to analyze the motion of this blue box, what should you draw? Should you draw the rubber band? Should you draw the finger, or should you draw the table in the free body diagram? The answer is no, because you would like to analyze the effect or the motion on this blue box only. So let's draw it, a blue box. 我淨係想知道所有嘅力加喺呢一嚿嘅藍色盒上邊嘅影響，總體嚟講係點啫？係嘛？我淨係畫呢個 box 咧就夠㗎啦。Oh, and obviously there is force of gravity acted by the Earth, but why it will not moving upward or moving downward？ 明明擺張台度啦，係咪？亦都應該有地心吸力啦，拉住呢嚿嘢。點解佢唔會向上升向下跌嘅？呢個藍色盒。好 and just try to draw these two components first. First one is that there is a force of gravity. Well, actually, we can call it weight. But why it will not fall down? And obviously, in this case, is it a table is below, and then to support this box, and then to give it a supporting force. Oh, and because supporting force is contact force, so we start from the place where the box and then the table are in contact, and there's a force exerted by the table or the desk on the box. And these two forces should be the same in length to represent that these two forces have the same magnitude, and then these two arrows should be in opposite direction so that the effect of these two forces can be cancelled out. And one thing is that when you're drawing the free body diagram, and then when you're naming the force, you can see that the force must be in this format. The force by something on this object that is what you want to show people, is because what you want to analyze is the motion of this box. So that we draw the free body diagram on this box. So for the forces acting on the table, acting on the rubber band, acting on the finger is not important. Oh, then how about in a horizontal direction? What force is acting on this box? What about the rubber band? To what direction the force is pointed to the left hand side. And the point of contact between the rubber band is at the very right end of it. Oh, how about the finger? Right hand side to the right hand side. So let's draw these two forces. So the force by the rubber band, and is pointing to the left hand side. Sometimes we can call it tension when you are using a string or a rubber band to hold an object. It's called tension. 要張力啦。Oh, then how about the force by the finger? Well, it should point to the right hand side. And then the force should be added somehow here. So in the diagram, it should start from the position of the purple dot. Oh, and this force is pointing to the right direction. However, what should the length of the arrow be in order to make the above object remain at rest? Oh, it should be the same length with the green arrow so that these forces can be balanced. Is it okay? And this is the force by a person, and it is actually me on the box. And this green arrow and the purple arrow should be opposite in direction and with the same magnitude in order to make this box remain its original motion state, that is at rest. So here come the free body diagram on this blue box. And again, the format is that it is the force exerted by something, the rubber band or the person, on the box。我哋諗緊嘅就係話，我究竟有啲咩力咧加喺呢一個藍色盒上面啫嘛，係嘛？其他嘅嘢我哋唔着緊嘅，咁所以個 force 嘅方面一定係由邊一嚿嘢俾呢嚿藍色盒嘅力。The whole analysis for the vertical direction, the weight or the force exerted by the earth is cancelled out by the supporting force by the table, and then the force of the rubber band is cancelled out by the force exerted by the person on this box so that it will remain at rest. So what happens if I suddenly remove the force exerted by my finger on these blue blocks? And obviously you know that it will be pulled to the left by the rubber band. Oh, and how can it be explained by this free body diagram? Is that, okay, suddenly I remove my finger from this blue box so that the purple arrow disappear, and is at the moment I release the box， 得唔得？我一放開手，我就冇力咧再加喺呢一個嘅 blue block 上邊啦，係嘛？Oh, then what is the overall effect? What is the net force? Originally, the net force is 0 because all forces are balanced. Then now, the weight is still balanced by the supporting force, but for the force exerted by the rubber band is no longer balanced by the purple arrow. So what's the net force? Okay, to the left-hand side with some magnitude. So this blue box will accelerate to the left-hand side. Can you see the idea? 同埋呢一個亦都喺個 free body diagram 上面度 show 俾你睇啦，係嘛？紫色嗰個我一放手唔見咗啦，嗰個力得翻青色，而家呢支就係個橡筋俾呢個 blue box 嘅，佢自然就會向左手邊加速。